with that, I will yield the floor. Let him run back, and you'll probably be out. Cool.
Yeah, hello, my name's Mark. I work at a place called Victor in Australia, specifically on the team called Lambiata. We do machine learning, large-scale data processing. This is kind of incidental to what we do, but it's kind of important because without it, we'd be really bad at what we did. So the enemy is the gramophone mind, whether or not one agrees with the record that's being played at the moment. This is something that rings true for me, and it's how I think about tooling in programming in general. Basically, I think that we're caught in a mind trap where we think that everything we use right now is bad and the next thing is really good. Right? This whole process of me building Annex is about being a little bit more critical of how I build tools and thinking about it a little bit more deeper. So, motivation, or we're doing it all wrong, or we're all doing it all wrong, or I'm at least doing it all wrong. So 2.1.3, I'm pretty sure everyone in the room might have a story about how it came to be. Bob probably pushed a really quick fix. Jane may have pushed the UBIT feature, and I assume the marketing department got a hold of it at some point. That's how we got up to 2. But I think this is a pretty bad joke, right? We have data structures, rich domains that we model every day, yet we pack all of this semantic information into a number. Seems pretty ridiculous, really. The next thing is time is pretty critical, and time is something else that we ignore when we come to dependency management. So if I look at the lifecycle of an artifact, I might commit some code, it might go and we run some tests on the CI server, and then I might publish an artifact or not, depending on how you do it, and then eventually might do a platform test, publish it to production, and then we might get some performance numbers from production, and we let somebody write some C, so we've got a vulnerability. Whoops, probably shouldn't do that. But the point is that right back here is about where we stop recording information normally. Right? That's pretty silly. I want to record all information for all time, and I want to have it at my fingertips all the time. Next thing is about languages. We all live in our little groups, and we're very sheltered. I think this is very sad. I've deployed 7 different languages to production since I woke up this morning. And I was pretty tired. I had to use 6 different dependency management systems, and they were all really bad. So I've probably got a lot of bugs. But the problems that we're solving, and most of the problems we solve with developer tooling, are problems that are across languages, and we should start treating them as cross-language problems. So again, this is something I'm trying to address. Next one is closed-world assumptions. I'll pick on some specific things that are coming along, things like Nix at the moment. It has a lot of really good properties, but one of the things that really bugs me is the idea that we can shut off what currently exists, and we pretend that the big bad things that have already gone on for the last 20 years haven't happened. So I want to be able to accept that bad things happen, we're going to build new systems, but they have to integrate with the current world. But the basic underlying of all this is that dependencies cost too much. I think I've heard it at least 2 or 3 times in talks this morning where people talk about not having too many dependencies. And we're talking about functional programming, but it still bothers people. I want dependencies to be cheap. I want to just be able to reuse abstractions. I don't have to think about it. So the concepts that underline Annex that start to try to solve these problems. So here is a kind of a general dependency graph. These are 4 projects that exist in my team. Napoleon and Snowball are sorry, they're real names, sorry. From Australia. So Napoleon and Snowball are some web services. Boxer is a tool that kicks off long-running jobs. Eminence is an identity management system. And they kind of sit like this. There's a little diamond. This happens a fair bit. But this is a part of a larger one. We use Y, we use Haskell base, we use Postgres simple, which in turn depends on libpq, which depends on an operating system. That operating system was built with a compiler as well, right? The dependency chain keeps going. At some point we want to draw a box around what we're trying to resolve, what query we're trying to make. So the first thing is that Annex is a fact store. So we start with something we can have. We call this a family. So a project name, Boxer, but when we're real programmers, so we won't use strings, we use UID, so everything in Annex is very individually identified. Names are just surface syntax. Okay. So then we have atoms. Atoms are things that we resolve. So families are what we're trying to resolve. An atom is a specific instance of that. Again, we use IDs because they're better. So then we start recording facts. So facts could be things like the git commit hash, an API signature. If we're doing Haskell, probably the ABI signature, kind of important things. This is a very rich data structure, so it's a tree that's recursive over it and all of its dependencies. So that you can do matching against partial APIs. This is kind of important. We don't want to just say, here is our thing, take it or leave it. We want to go down to the function level, work out where the two things link. Right? So one of the important questions for me is, will it link? Right? Will I end up with a situation that I'll get a runtime error or not? And I might be able to put feature flags in here. It works. Facts are kind of arbitrary. When we take those facts and we put them against atoms, so it might look something like that, but you can think about it like this. So Boxer has a commit, has API signature, has the it works feature. It's pretty useful. Okay. And then we take all of these and we just put them in a world, right? So a world is effectively a single point in time of this, right? So a single point in time where we have all of the facts at one point in time, and then we migrate these worlds over time. But the world is static and will always exist. So world v1 will exist today, it will exist tomorrow, exist forever. Right? So an example of this would be, take Boxer is at v1, then we go and test it on FreeBSD, and we want to add a new fact. So that migrates the entire world. So I can still run a deterministic query against world of v1, I can run a deterministic query against world of v2. That's pretty important. So it's kind of hopefully becoming clear that a lot of the design decisions are predicated on predictability and reliability. So the reason why everything is so granular, everything is so defined, is that we want everything to be very well understood before you ever run a query. And then when you get to the end, you want it to be absolutely repeatable. So no matter what people do, they should be able to repeat it later on. Okay, the next thing is that Annex is a data store. Hopefully this is kind of straightforward. It's basically content addressable storage. We use the hash or the actual content of the data as an address. We store that as a fact, and then it becomes an address later on, so that we can just look it up. So we might store an artifact, we'll have an address, maybe the flags that you use to build it. This kind of becomes important later on when you want to do things like source for binary substitution or binary for source substitution. You need to be able to predict what the signature will be before you ever build it, so you know whether to go and ask for a substitute, for example. And then that will point to some storage location, and that kind of gives us some nice properties such as fairly predictable caching, right? One of the things that the rules that we hold true is that if something's on a person's machine already, we never ever want to download it again. So in Australia, we don't really have internet yet. We're going to get it soon. But it's really, really bugged me when I have to download something twice. Cabal sandboxes drive me up the wall. Maven drives me up the wall. I don't want to ever have to download something twice. Okay? The next thing is Annex is a language. So it's basically a logic language where we can define facts, query over facts, and write new facts in terms of deductions. So instead of writing traditional, people might write a Cabal file or a SVT file if they're using Scala, or some Maven file if they're using Java, and they would write version numbers, right, semantic version numbers. But because semantic version numbers aren't good enough, these are the sort of things we want to say. We want to say that we have this feature, it came from this branch, it's binary compatible with this, or it's source compatible with this. We can still interop with the old world, so maybe some things still live on semantic versionings. But this is more what an Annex version file looks like. Yeah, and then we also have a first class notion of time. So I can say, run this query across this time frame. So it will always give me the same answer, even though I haven't been specific. If somebody adds a new version of Napoleon, I'll still get the same one because of this. Yeah, and that can also happen for a specific entity. And then the really more interesting query are things like across time, but at a different point, different axis. So I might say run this entire query at v123, but I then want to also run a query across all time to say, just as a safe check, to say I don't have any vulnerabilities. Right, so if somebody's learned about a vulnerability, even though I'm reproducing my build from 6 months ago, if in that time I subsequently learn about a vulnerability, I'll get an error saying you need to do something about this because you still can't ship it. Okay, so we want to start putting some of these as first-class citizens. Okay, it makes a few assumptions about the things that you can query across time, because things across time are obviously not reproducible, but with a constraint like that, it's kind of important. So this, one of the important things of that file that I just showed you is that precision is very important. I want the users to tell me what they need, and very precisely. I don't want them to have to add arbitrary constraints or add fake upper bounds or add different things just because it might break in the future. They should just be able to tell me just what they want, and the answer should come out. And flexibility should never come at the cost of determinism. So this is basically all of the systems that I've dealt with ever pretty much deal with, I can be rigorous and I can specify very tight constraints, get the same answer, or I can be flexible where I can have wider bounds and it might break later on. I don't want to have to make that trade-off. I want to be flexible and I want to be deterministic, and I don't think I have to make that trade-off. And the last thing, Annex, is basically a tool, right? So it's a command line tool. I won't bore you with too many details, but I can fetch dependencies at a point in time. It'll just pick up the things, and I can remember what version I'm at, so that next time I can just say, it'll store off a stable version, so that next time I just have to run fetch. I can commit that, and everyone just has to fetch, and I'll get the same things every time. Okay, but if you notice this file that I generated, it's like one line. It's exactly what you'd write on the command line. So that's another important design decision. Never generate a file for a user that they wouldn't write by hand. This has a lot of nice follow-on, basically, because if they won't write it by hand, then it becomes very hard for you to dynamically generate another one later on. So I'll talk about it a bit in a minute, but if I want to say, for example, when my CI server run my stable dependency loop and say, get the ones that I got last time, but also run it against head or run it against some other point in time, I don't want to have these two massive files of 100 commits that I've locked in or something. I just want to say, the point in time of the world on that, let's reproduce at that point in time. Okay? And a few things about performance, I guess, which is that we want it to be instant by design. So if I fetch at one version, then fetch at some other version, then fetch at that other version, I should definitely have already downloaded everything here, so it should be instantaneous. Never repeat work. Okay? Some other commands to create atoms, create facts. And the other one is we want to do deep linking with the current tools. So all of our projects use Git, so we want to be able to do things like just annotate our Git commits. So we might not have published something into Annex yet, so we just want to say add a note, which is this has the feature win in it, and then later on in the CI server, it will say add all the facts from head and push them to the server. So we want a deep integration with our current tooling. Okay. Yeah, so leverage tools, but don't use Git as the baseline for command line tools, please. Do better. Okay, so resolution should hopefully be kind of obvious, but it's important to explain the next bits. So we can retrieve facts from different stores. We can also send queries. So there's kind of an important design decision in the whole system, which is that we can distribute the query and run it either on the client or on the server, or a mix of both. So I might decide to send the query to the server because I can do it quicker, or I might do it locally and just retrieve the facts as I need them. And then I can synchronize artifacts in a fairly reproducible way. So some kind of development models. What would I do when I'm actually using this to develop code? So a common scenario, got back to my slightly simplified dependency graph, might have some dependencies that I've declared. I just want these features, I don't need very much at the moment. So one of the things I want to be able to do is run against multiple dependency resolutions when I test. So I might want to have my stable build run and fetch the exact same dependencies as I did last time, but I also might want to have an edge build that goes and fetches the latest one. So I know that whilst I build, just like I did last time, I also, if somebody's added a new version of some tool that I'm using and it still satisfies my constraint, I want to test if I still work, right? I've promised that I've worked with it because I haven't added a constraint, so let's test that we still do. Okay, and this falls out into some really nice things, which is then I can start reporting on the state of a particular atom in the world. So this is something I'd like to see with Hackage, for example, is that it's kind of hard if I go to Hackage, I see that there is a version. I don't know whether when I go Cabal update will I actually be able to resolve that. Whereas with this model, because it's so deterministic, I can say, well, at v123, I can definitely resolve this graph. The server has already resolved it, and the server's going to get the same answer as me because I'm fully deterministic. Okay, and it doesn't resolve at 124. Maybe somebody did something. Okay. Okay, so that's just about designing for simulation, designing for metrics all the time, which is kind of pretty important. Open world, so Napoleon, it's a web, has some webby stuff in it. We don't do very much webby stuff, but we do a little bit. So we do some Y, and we have some JavaScript. Right? So normally I would have to, if I was going to use some different dependency manager, I'd have to go outside of its bounds, but I want this to deal with existing systems. So I can say that Y still lives on package. I don't expect people who build Y to all of a sudden start using Annex as soon as I do. And same with underscore, they're going to publish it to some CDN.js. Right? And basically I want to be able to declare these external dependencies and interop with the current state of the world, even if it's not as principled as I'd like. Okay? And then I can still add facts over time. So even though this is stored on some other server, I can say that I tested it here, and then I can use that in my subsequent queries. Okay. Okay, so a couple of advanced features that we use that I like quite a bit. First one is source substitution, which in some systems is easy, in some languages it's a lot harder. So I do a fair bit of Scala, because we use Hadoop, and source substitution with SVT is quite painful. But one of the things that you want to be able to do is say, I'm working on a feature in my top, Napoleon, I hit some bug on some transitive dependency down here, what do I do? So if I'm living in the rigorous world where I have very rigid dependencies, I'd have to go and fix it up here, roll it up into here, or roll it up into here, and then eventually get it up here transitively. This is kind of fairly unpleasant. So I want to just be able to say fetch with the source substitute, or fetch with the source substitute, and ignore the current constraints, maybe they don't satisfy. So I can just do my bug fix, and then say, oh look, the bug fix is in here, so transitively, when I resolve eminence for Napoleon, make sure it's got that commit in it, or I can add a fact, make that a bit more nicer, so it has fix 112, for example. Yeah, and then I can just ship it. I never have to worry about these. The Annex server will tell me if it resolves still and meets all the constraints all the way up the tree. Okay. Binary substitution becomes a lot harder. So binary substitution is something that is kind of important for native code. So things like Haskell, where we build a lot of things, but we have different flags, different operating systems, a bunch of different things. So for binary substitution, it requires deduction of the output signature before we build it. So this is actually a lot harder than it sounds. So we have to know what our final API is going to look like, what our final executables are going to look like based on our operating system, our flags, everything before we do it. This actually involves all of the transitive dependencies, inlining, all sorts of problems. So because I'm building Napoleon, it indirectly depends on eminence. Changing which eminence I link against will change the binary signature of Napoleon. So this is quite a difficult problem. And at the moment, we kind of punt on it a little bit, and we end up using like Nick style build the world, or I'm hoping to get better language support. So I think some of the backpack work will help this a little bit in terms of coming up with predictable signatures, but that's what we need to be able to do to have binary substitution. Yeah, so people might have noticed so far, which is, probably talking really quickly, giving you lots of facts, but one of the things is that Annex is a distributed system. And in distributed systems, time, especially linear time, is quite difficult. And so we kind of we kind of forego being a full distributed system when we take federation. So we take a federated approach, which I'll try to explain. So basically, whenever we have a version, it's localized to some given store. So if there are multiple fact stores, say you have the central one, your internal one, effectively, rather than having one global version of the entire world, we split each world into, this is the world version on this fact store, this is the world version on this fact store. So we get infinite read replicas because you can still query everything and replicate across, but we only have writes going to one specific server for any given atom. So when you say create an atom, it has to, all of the subsequent facts have to go back through that, and we add versions subsequently. I'd really like to solve this problem. It's probably one of the worst things I think about the system. And one of the ways that I'd like to do it is come up with a more refined fact model that I can say always commutes. So I can say I can always resolve this after the fact, and then I can end up with slightly non-linear history of versions. So that might sound a bit weird, but if two servers got out of sync, they would generate two different versions, and then when they came back into sync, you'd get a third version that had both of the facts. And as long as I can merge those, that's okay. It would force the user to deal with conflicts, but given that these are fairly irrefutable things generally, like it built here or it didn't build here, they generally work out. So I'd like to do this, but I'm probably a fair way away from it at the moment. Next thing is trust. I did a practice run of this presentation a little while ago, and people who normally just download stuff from the internet and just run it, all of a sudden were really worried about trust. So I thought I'd say a little bit about it. So basically the trust model is that we do authentication on family and atoms. So when you own a family or you own a particular atom, you're authenticated to do it. People can add their own views and extra facts on it, but the official facts are only come from authenticated users. If you want to trust other people, everyone can sign facts, and then you can trust certain signatures. And then there are mediation and fact views. So if I'm inside of Ambiata and we don't want to trust the outside world, people could put anything in there. We can add an internal fact repository and then filter the other facts by some situation. So we only want to trust facts from here when they're owned by somebody or they're signed by somebody. Okay, so these mediation views become pretty important to trust. Solving, I won't go into too much detail probably because I'm way out of time, but basically DPLL, SAT-based solution. There's a paper called Opium that gives a fairly good algorithm, but it's really slow and doesn't really kind of work. So I'm using a SAT solver. The hardest part is mapping the facts and the logic onto SAT problem. It's kind of okay. It's just using identity, and people want to use things like IE6. I want something tested on IE6. What does IE6 mean? Coming up with those identity and ways to deduce and merge when somebody says IE6, somebody says Internet Explorer 6, what that actually means. And I'd really like to come up with a way to cache partial solutions. So given that sometimes the resolution can take a little bit of time, it would be nice to be able to just have the answer cached, at least partially. And reproducibility of the solver. Given that everything has to be reproducible, the one variable in everything is Annex itself. So at the moment we solve this in a pretty kludgy way, but we put the Annex resolver with a specific version in here which maps to what algorithm actually gets used. So at the moment I'm promising that whenever I release a resolver, I will continue to release that resolver bug compatible forever. I'm not really sure how I'm going to resolve that, but that's what I do at the moment. Okay, look forward. This is kind of my far out imagination and where I want to go with things. But basically I want to do deeper analytics. So the first thing is, if anybody's ever wanted to talk to their CI server, I want to talk to my CI server all the time, but ask it questions like, how many times is this broken? How many times have I run tests on this specific bit of code? And I just want to have that data at my fingertips, and it should give me that insight, because all of those things should be stored as facts. And then I want to go on to the next step, which is starting to infer things from customer reports. So if a customer raises a bug, comes in, I know what versions of software they're using. I can see that there are other related bugs at that version of software, kind of have that sort of information at my fingertips. And then starting to predict failure in advance. So I know that if I ship something after 5 green builds to production, it's got a much less chance of breaking than if I add red, green, or something like that. I want to be able to start doing analytics like that. Fixing all the compilers. So I mentioned it quickly, but the whole idea is that compilers and compiler writers, and there's probably a few around here, it would be really, really nice to have binary and source compatibility, have the ability to have modularization built into the language in a way that we can use it for downstream tools. That would be really great. And easier extension via deductive rules. So I have the logical base for the basic facts that I use for querying, but the idea to generate new facts from old is kind of also important. So I might want to say that I want to create a new fact which is tested on Linux, which is basically tested on any kernel in the 3.0 range, right? So people can put their fine-grained facts in and I can deduce wider facts from it. And I want to make that fairly pluggable. And the commutative fact model to make things non-linear. That would be really important to actually making it a lot easier to use. Okay, that's it. That's everything. Sorry for blasting you. I know it's pretty full on. But yeah, if any ideas kind of pique your interest there, I think steal them. I think thinking about our tools a lot harder is really important.
Thank you.
Just one very quick question. I'm involved with the OPAM, which is the OCaml package manager,
yep.
and we call it to something called CUDF, which is a standard exchange format for sat solving, so everyone doesn't build their own slightly half-baked sat solver. So have you thought about just using some of these tools? Because the Debian project in particular has a lot of really kind of big, well-engineered, scalable tools for this.
Yeah, I would like to. So my problem at the moment is a few things. So most of the SAT solvers at the moment are pure algorithms, and I want to be able to go off to servers lazily, and I want to be able to ship the computation across server and client,
Right.
which is at the moment I have a fork of one of the Haskell SAT solvers.
Right.
And I would really like to do that, and I would like to have a bit more of a formal model about how I distribute the computation, and then I would be able to use it straight up. But that's my current sticking point.
Sounds great, thanks.
Thank you.